Is this Ron? Yay, Ron. Ron is here all the way from Israel. Yay, that's awesome, right? He's come here. He is the creator of like a library, I guess, called Bit, where you can create your React components, kind of alleviate the barrier to entry to sort of creating React components and what is a React component and where should like my composability for components be. So everyone give it up for Ron. We're really excited to have him here.
Thank you so much, Devon, for making this event happen and for the kind words. Thanks for Walmart Labs for hosting this event. And thank you all for coming. I appreciate it a lot. Today I'm Ran. I'm the founder and CEO of CodeCycles. I'm the author of Bit. And today I will tell you a bit about Bit, what it is, and Bit is a software composition tool. We'll get to it. So, I think it would be best to start with a story. So the story is the story of Left Pad. I guess some of you may heard of the story. And I'll start from the beginning. 1.5 years ago, something like that, I guess, a function which was part of a package called Left Pad. The entire package had these 11 lines of code that you can see right now in front of your eyes. And lots of other open source, important open source projects like Node.js, Bubble, and many other important projects were dependent on it. One day, after a conflict between a Chinese company and the author of the package, the package author decided to pull the function from NPM, and therefore the entire open source was braked. Right, Node.js braked. The build was braked because once you tried to build your product, you had to npm install all the modules, and one dependency was missing. So everyone started talking about it. It was a very big deal in the media, and a very interesting discussion has emerged. The discussion was whether we should take such a component, right? It's just 11 lines of code. Whether we should take such a simple component and install it install a whole package in order to do so, or we should just copy and paste, right? We used to do so. We go to Stack Overflow, we take 11 lines of code, we copy and paste them into our code, and it works, and it never breaks. But we know that copy and paste has some issues, and we know micro packages has some issues. So I'll try to cover these issues and how Bit may ease the problem. So after this discussion has emerged, I wanted to check out and see how many times, how we as a community, how do we solve this problem, right? And how as a community do we solve this problem? And I thought, let's see where the smartest developers in the world write code. And I thought the smartest developers in the world write open source. So maybe I can take the top 10,000 repositories in GitHub and see how many times the same function was implemented. So I took the following example. A function that's called isString. It gets a value and determines whether the value was a string or not. And checked how many times it was implemented across 10,000 open source repositories. And I found out the same function was implemented, was duplicated or implemented, you can choose whatever you like, thousands of times across 10,000 repositories in 100 different implementations. First, I never thought it's possible to implement this function in 100 different ways. I encourage you to do so. But it seems like the humankind is extremely creative. And we are able to do such stuff. And it was duplicated over thousands of times. So we did the same task over and over again. Each of us has just implemented the same piece of code. And we thought, well, this is in the open source. But hey, we are smarter, we are working for companies. And when we work for companies, we want to make sure that our code is super maintainable, right? That we fix something in one end and everything gets fixed, everything gets tested, and we want to maintain as little code as we can. So we went down to chat with companies we work with today, how much from their entire code base is actually being made of duplications and re-implementations of the same code. And we found that in the average organization, and here it's a real use case from a real organization, that works in a multi-repository architecture. It has 25 repositories with the numbers you can see in front of you, and we found that a third of its code base is duplicated. We found that in average, between 30% to 40% of the code bases we maintain are just made of duplication and re-implementation of the same code. And the implications are overwhelming, right? Because now first we maintain a third of our code base is just redundant. We don't need it, but it's there. And we still spend so much time maintaining this code. Once we update a function in one place, how can we see the update from the other hand, right? How can we know that an update has occurred? So we have to go and maybe maintain this component 80 times, update this component in 80 different places, which is extremely difficult. The second thing, we are creating a huge technological debt for our company, right? Besides maintaining field of our code base, which is totally redundant, now, of course, in every update, in every breaking API change, we have to move across different repositories and keep and fix the same piece of code. And of course, we don't know about it, so bugs are being caused in production. And of course, we waste lots of time and lots of effort doing the same thing that many other developers did before us, instead of focusing on innovating and doing the next thing, the thing that no one did before. And now you can say, well, as said, it can be solved, right? We can use packages. We can use micro packages. We can take small components of code. We can share the component of code in a package, and we can reuse it from any other project, right? So it's not that simple, apparently. Let's imagine I'm working now on a project, in the company I work for, and I just implemented the beautiful left pad function. And I would like to share it with all my friends and with all my colleagues, and maybe create a source that I can always find and use this component. What would I have to do? First, I would have to go and create a Git repository, right? This is the first step. I would go to GitHub, I would go to the Git registry of my organization, and I would create a Git repository. Then I will have to go outside of my project, clone it into a different file system path in my file system structure, and start boilerplating, right? I need to create the tests. I need to create the build. I need to create different configuration files. I have the hint configuration file, I have documentation, and after doing all of this, I can test my code and check it. And after I've completed this, now I would have to publish this package. And I don't know how many of you have a private registry in your organization. Some organizations have and some organizations not. But even if I have a private registry, it's centralized. And usually I will have only one registry in my entire organization. So I would have to publish it, and everyone would be able to access it. But code doesn't work this way, right? Not always we want to share code with everyone. Sometimes we want to share code with maybe smaller, more intimate groups of developers, because I'm writing a proprietary technology, or I wrote a component that is specifically related to my team, and not for the entire company, and I want to encapsulate this bit of code from the entire organization. And even after I published it, now we published every component into a package. How do you maintain 400, let's say, 500, let's say, different packages with 400 or 500 different repositories, with maybe 400 or 500, let's say, CI accounts, right? Because I need CI to run my tests and build. It's almost impossible. No one does that. And the second thing I would have to do in the process of the maintenance is probably fix bugs, right? Now I'm a consumer of a component. I just decided to use the great left pad function that Devon implemented. And I installed it on my project. And now I have a bug. Who would believe that? Software has bugs. And how can I fix it? Right? It's in node modules and not tracked by my Git. I would have to first find and detect the Git repository. Then I would have to clone the Git repository again to a different file system structure. Then I would have to be aware to the build and to the testing environment that the user decided to use. And I would have to get to know that. Then I would make my fix, link it to my project to reproduce the bug. Then I would fix the bug, get over that, go back to the repository, commit the change, but hey, I don't have write permissions. Okay, I have to make a pull request. But when they will accept this pull request, okay, then I'll just copy and paste it into my code and I'll put it in this vendor directory I have, right? We all have this vendor directory with all the code we copy pasted from everywhere. And even if I work that hard and I'm maintaining maybe 500 of these packages, now how can I find them? right? How do you discover code? Code discoverability is a big problem. Usually we won't do that. We use shared libraries. Static shared libraries we share lots of components into, like Lodash, for example, or like React Material UI. React Material UI, for the guys and girls in the audience that knows it, has over 1,000 components inside of it. Some of them are not public within the API, but it has over 1,000 components. And once you install the slider, you will have to install the entire package with all these 1,000 components, which make you commit to the other components in the library, although you may not need them or want them. And of course, once you publish a static package with 100, 200 API endpoints inside of it, how can you find it, right? Because NPM indexes that as NPM and other registries, of course, indexes that as React Material UI. And this is how it's been made discoverable. And Google indexes that as React Material UI. And if you will look in Google for React slider, will you find the best slider? Will you find the slider implemented in React Material UI? I guess not, because Google don't index the code this way. And of course, it makes it very hard to find it. But even if I did find it, how can I know how good it is? How can I know what edge cases it handles? How can I know if it fits my use case? I don't have any way to know exactly what edge cases it handles. I don't know what's the quality of the package I'm picking. And the only measure I have today is the unit test, but all we know is the tests are working. But what is being tested, right? This is the important question. Because I can write thousands of tests that does nothing. And it's very difficult to know exactly what can I do with that. So to solve these problems, we built Bit. Bit enables me to turn my existing source code into a dynamic collection of code components you can easily find, use, and implement for many other projects. You can imagine that as instead of writing collections or maybe libraries, static libraries with lots of APIs, as an items playlist of components. You can share components to this playlist, you can use components from the playlist, and you can develop components from any application environment. I'll show you. So I'm in my terminal. Can anyone see? Can everyone see?
Yes.
Okay. And I would like to make some of the code in my terminal accessible to my other teammates. The first thing I would do, I would initialize my bit scope, my bit environment. Now we can see that, a bit scope, a bit environment was created on my project. What is it exactly? Bit enables you to create this is what Bit added, a .bit directory. It handles all the models and all the information Bit needs in order to make your content accessible from anywhere. And this is the virtualization level of Bit. It actually decouples the representation of components from your file system. So it enables you to say, the component pad left is built of these files in these file paths on my project. Now I'm having here a React project. I'll open it in my IDE. It's a straightforward React project with a lot of components I can find in this components directory. Let's see it in action. So this is it. It's an open source project, by the way. I found in GitHub. I didn't write this code. We can see that it's mirrored Netflix and talk to the API of the MovieDB. It's obviously built from lots of components, right, that are currently just hard-coded inside this repository, like the hero component, like the title component, like the title list component, the logo component, I have an navigation component, and many other components that maybe I can benefit by working with my teammates. So if I'm working for Netflix, I guess I would have similar UI demands from different applications, right? I don't want to, we have one style guide and one brand for the company, and we would use the same component from different projects. So let's try and make them accessible. Okay, so all of these components are in a pretty straightforward structure in my components directory. In order to start tracking these components by bit, all I would have to do is use the command bit add. Bit add accepts a glow pattern. I will now give it source components all. We can now see that bit has just tracked 7 new components. Let's try bit status and see how it looks like. We can see all the components down here. We can see that bit just identified 7 new components. We have the hero component, we have the hero bottom component, the namespace was taken automatically from my parent directory, and the component name was taken from the name of the directory itself. Next thing I would like to do is commit these components in order to move them into the virtualization level bit. And now I would like to export them into a newly created bit scope, or bit playlist. So I'll go to bit.scio. Bit is distributed, and it implements the same distribution model of Git, if you know how the distribution model of Git works. So you don't need to work with bit source in order to start working with bit. You can just place a bit scope on any machine and connect via SSH. But to make it easier, we made bit source. Bit source is our bit hub, if you like to call it that way. And it enables you to easily find and share components into the playlist I just described. So let's try and create a new playlist. I'm going to call it maybe reactjs. I'll make it public, I'll make it private, and I'll create it. That's it. Now I have a new scope created, a new playlist, a new shared collection of components, and it waits for components to be pushed. I'll go back to my terminal and I'll export all the components I just created to my name, this is my username, and the scope name I created, reactjs. That's it. You can now see all components are being made accessible from the hub we have. You can find each of the components that come to use in the project I just showed you. For example, we can look at the hero component, or maybe the hero button component. Hero button is a small call to action with on top of the hero banner. We can see that we've rendered the documentation right from your JS docs. We can see the properties that this component receives. Really was rendered from the JS docs and the code itself. It was a bit source code sensitive. We can, in the very upcoming future, we would also enable you to really see the component. Just here, we would render the component, and you would be able to view it and really see it in action. If we look on a different component, for example, that looks more like a utility function that I exported before, we can also see that bit runs my unit tests, and it uses my unit tests to help me understand what edge cases this component handles, and maybe give me a way to monitor the functionality of this component. So we can see this component converts a short hex color to an RGB color, and it passes. And we can see that it converts a long hex color to an RGB color, and it passes too. For the component I just used, I don't have a unit test, and therefore I don't have a test summary. Going back to my hero button. So we can see the description of the hero button. We can see a console output if we like, because bit isolates my component and runs it from anywhere. But now let's take the hero component we just saw, the big banner, and use it from a different application I have. For this purpose, I would use bit import. In the very soon, we would enable you to install bit components with npm and yarn if you like. But currently, you can only import components using bit. So I'll go to a different project called Path. It's just a plain React app without anything inside of it. I'll start it so we can see it. Just empty. And I'll import my newly created component. Using bit import, I can import the component to any file, to any path in my file system structure in my project. Oh, sorry, bit init before, of course. I chose in my bit.json configuration file to import this component into source components hero, and now I can just easily use it for my code. So I've opened my IDE. This is the main component of this application, and I'll import hero from components hero. That's it. Now I can just compose it inside, and we can go back. And we can start it again and see the component renders. Okay, great. Now I had a bug in my code, right? Remember that use case? I just had a bug, and I need to fix it inside the component. Or someone, the product manager, just asked me to change the functionality, asked me to remove the plus my list button right there. So I'll open that. Right from my IDE, we can see that the components was created inside the components directory. We can see the namespace components, and the name of the component is hero, and we can see the code just inside. Here it is, hero. Let's remove it. That's it. Removed. Now we can do bit status, and we can see this component was modified. I can easily commit it back and push it to another scope. I can push it to the same scope I just took it from, or I can just keep it inline on my project and commit it to Git, because I just override it and change something, and I want it to be more specific to my project. Components are highly discoverable in Git. Right now, you can search components using the Git search. I can search for if I need a function that determines whether a string is a value. I can just write check string. We can see that Git understands the functionality of code. It really understands the query I just searched. And although I searched for check str, I got components called a string that I can easily use to do anything. If I would like to commit back my component, all I can do is just git commit, update it, and of course export that in there. That's it. So looking forward on our roadmap, very soon we would have yarn and npm support on bits. We would support component rendering. So the components you would create and share to these shared collections of components would be easily, you could easily experience them and see exactly what is being made. We would have event-driven updates. So you would be able to get updates if your friend just updated these components. But instead of pulling components, instead of taking components in a pull, you would get it in a push. So you get a notification that your friend just updated this component. Would you like to update in your application? And you would be able to do it with one click, or apply a method for automatic updates, in case you would like to be updated automatically. We would add a bit UI to give a better experience for creating and maintaining bit components. And that's it. We are looking for contributions. We look for feedbacks. If you guys are interested in solving this problem, just give it a chance. Ping us in. You can reach me on my email. You can reach me on my Twitter. Looking forward to these feedbacks. Thank you so much.
That was so awesome. I didn't even understand it from the abstract, but now I'm like hecka stoked. Like adding it. Like I can see it like being great for even like sim linking or something between two components without you even like looking out the outside world. Anyway, it's incredibly awesome. Does anyone have any questions for Ron? One up front. Just go over. There's microphones on either side of the room and then one in the far back. So if you guys want to line up, that might facilitate easier question answering.
Awesome tool, by the way. But so how does versioning work right now for the components, and like how do you track versions if that's a concept in Bit?
How do I
track versions of components if you had to? Do you always get the latest version, or can you like go back?
Okay, great question. So first, one of Bit's features is on-commit dependency resolution. What it means? It means that once you commit a component, we automatically detect all the dependencies. As you've seen now, I've used the hero component, which is dependent on the hero button component, right? I never defined any package JSON. I never had to add the packages and define exactly what dependencies I have. It just did exactly everything I needed for me. And it did everything for me. And once I committed it, it detected the dependency and ran it. And once I export it to my scope, Bit always have this component alongside it. So if the component would be updated, the other component I just used won't get the update because it's not automatic and you can't define ranges. You would get a notification and you can apply a method for automatic updates. For example, I would like, once you change the implementation of your dependency, I will get a notification. I can apply a method that determines if the tests are compatible. You can take the latest version implementation and run it versus the unit test of the oldest version and determine whether it passes. And if it passes, it's good to go. I can make it run my CI unit test and my end-to-end unit test and see if it works. And if so, update. If not, don't update. And the most basic updates method would be getting a notification and manually deciding whether I would like to accept this update or not. Of course, it would be settled by categories of severity.
I have a question as well. I had a question as well.
Yeah.
I guess two questions. How much overhead does it have when you bid it in that .bit file? Like, how much overhead does it bring? And also, like, how many components are currently in that, like the bit source that we saw?
How many what?
Components. Like, how many?
It's very early days. We now have over 1,000 components. We are a venture-backed company, so we are keeping maintaining the product. We are about 10 people working on that right now. The complexity it literally adds none. Right? As you see, my code never changed a bit. I had my application, I had my components inside of it. I never had to create new repositories, work hard to try to change my code, change the import statements, nothing. Bit just did everything for me, automatically detects my dependencies, it knows to resolve everything in a way that it would always work, and I can just make all my components accessible to my friends without changing anything. Reducing the overhead of doing so, and of course, importing the component back from another project can be done also with NPM. So many people has expressed issues of worrying about adding another dependency to the project. But you don't have to do so now with Bit. In 2 weeks, you will be able to install with NPM and Yarn. I can tell you that our current user base are really using Bit to import components because they can keep it in line, make modifications on the fly in case they release more pieces of code. But this is currently the state.
Thank you.
I got a question. Over here. Great presentation. I got a question though about consolidating components. So for example, you showed check string and there were a bunch of results. Do you guys have any plans to offer some kind of tooling to consolidate those duplicates and maybe like tell or notify these different authors that you might have some similarities with this other project and you guys are solving essentially the same problem?
Yes, you're totally right. So the reason you saw so many strings is first because I'm making lots of demos and I used the function string and it was private Git components I used for my demos. But yes, you're right. It's a very important question, and the way we think of it is in the future we plan, as I said, to release the Bit UI. So one of the things that are very hard about discoverability is the fact that I don't want even to search, right? Sometimes the component is so easy to implement that you don't think about searching for it. And we plan to make searching implicit. So it would be, as you will write code with Bit UI, we would be able to say to you, look, what components are already implemented that actually implements the same functionality you're just trying to implement. And we'll suggest them to you on the fly, and you can easily compose them into your application. So this is planned for hopefully by Q1 next year. And we built a technology that knows to understand the functionality of code. If you saw earlier, I actually described how we found 100 different implementations of the same piece of code, right? It's a very big problem because the syntax is different. But we actually created models and ontologies that help us understand the functionality of code in a way that is more similar to how developers understand the functionality of code, like looking on contextual hints, looking on linguistic hints, like understanding how code was written, what terms we're using, and of course the structure of the code itself. And we are using it to actually make all these components accessible and searchable by functionality.
We have a couple more in the middle and then on the side.
Hi, thanks for the presentation. It's kind of interesting tool. I have a question. So the question is, what is the component from the Bit perspective? So what is like an entity you are publishing to the Bit? So I mean, for instance, if the components folder that you probably publish from your application has a tree of components, like a root level component, the number of components all the way down to the leaf level. So is basically every React component going to be a separate component that will be listed on a Bit?
Yeah, well, it's a great question. So first we have to understand that two things. Bit creates the virtualized layer I showed you, the .bit directory, actually creates a representation of components. So you create a representation of components, for example, we decouple things and give you this user experience by making this decouple happen. The second thing is composition. Of course, components are composed, and this is the point about building code out of smaller components. And dependencies has to be detected, and this is exactly what we do. So we detect your requires, we detect your import statements, we know to crawl it, and we know to define all the dependencies you actually used. And we also give you tools to control your dependency graph. So we know that dependencies can be, software is a dependency graph, right? Even if I'm not using packages, even if I'm not using Bit, still software has a complicated sense of dependency graph, and we let you control it, even on commit. So if you actually use the components and modify that, well, it adds maybe 5 or 6 dependents, you would be able to commit all the changes at once and update versions to everyone and maybe run the unit tests of the dependents in order to make sure your code is working.
So our last question.
Great, thank you. Yeah, I got 2 questions. So is GitHub, can you host it privately? And the second question is, what if your component has to be like built to Babel or run through a bunch of processors? Like, how do you handle that?
Great question. So I never covered all the features of Bit. But one of the features of Bit is Bit environment. You can specify a tester and the builder for each of your components. You define it in your BitJSON configuration file on the root folder of your project. And once you define it, we automatically use it in order to compile and test your component. To your second question, it's about BitSource. So yeah, BitSource would now currently BitSource is not supporting private code. Private code is in beta. We open it to specific people who ask for. You can go up to our website and sign up for private code beta, and we'll give it to you.
That was awesome. That was incredibly rad. Of course.
Thank you so much, everyone.